All right, so the unit circle, like I said, is centered on 0, 0. It's a length of 1 to any point on the edge of the circle. And the dashed lines here, we're going to write all of the degree measurements. So if you think of like an angle in that standard position that we did and sort of moved it around, we're going to go ahead and do that first. This will be the easy part of the unit circle. We're going to start here with 0 degrees. And then fill in the easy ones. Start with up here, the top. What's this going to be up here? All right, 90 degrees. Over here, 180 degrees, right? Down at the bottom, 270. And then all the way around is 360 degrees. Pretty easy so far. Next thing we'll do is divide each of these quadrants in half. So directly in the middle between 0 and 90 would be 45 degrees, right? So then in the middle of each of these, we're going to go through. The middle of this one is going to be 90 plus 45. What's that? 135. 135 is directly in the middle. Okay, what's going to be in the middle of this one? 225, yep. In the middle of this one, 315. So I'm just adding 45. Brian, you're supposed to go to your lab at 110. So we'll just see.
I'll still close it. I'll still close it in the order, but so I don't think they play.
So now we're going to fill in the rest of them. This one is not, it's not halfway. It's also not a quarter. What does it look like this would be about? If you were to sort of divide this into sections, here would be about a third, yeah. And it is. It's a third of 90, which is 30 degrees. This is exactly 2/3, so it's going to be 60 degrees. And then you'll start to see a pattern here. We go 30, 60, 90. What's that one going to be? Yep, 120. Okay, next one, we're going to skip the middle ones because those are by 45s. So next one is, yep. And then we got 180. Then, yep, 210. Skip the middle. 240. 270. 300. Skip the middle. 330. So that's the degrees. Oh, I wrote this wrong spot. So degrees are pretty easy, right? Once you get time for degrees down, pretty easy. And that's a third of them. Next up is the solid lines, which is radians. All right, so let's start with 0 radians. It's still 0 radians, same as 0 degrees. And then let's try like the 4 corners now. So up at the top is 90 degrees. You might not know the equivalent in radians, but we could figure that out pretty easily. Yeah, that's pi over 2. How do we get there? 90 times pi over 180. I remember the conversion. 90 over 180 is a half, right? So 1/2 pi or pi over 2 is how it's said. One thing about all these radians is we're always going to write them in simplest form. So you can't write like 2/4. You need to write 1/2. It's pi over 2, right? So over here is 180 degrees. Do that one next. If you don't know that one yet, 180 times pi over 180. So it's cancel. So it's pi. Right? And you'll start to see the pattern here. All of these are adding a half pi, right? So this is 1/2 pi. This is like 2/2 pi, right? Which is a single, 2 over 2. This would be 3/2 pi. So we say 3 pi over 2. And then all the way around is 4 pi over 2, which is 2 pi. That's kind of the start of our pattern with those. Next, let's go ahead and find the middle. So halfway between 0 and a half would be what? Yeah, 5 and 4, right? 4. So 5 and 4. All right, now the pattern here. Let's see. Start at 0. It says 1/4, 2/4, which is a half, 3/4 here. So we're going to 3 pi over 4. 4/4, which is 1. 5/4 down here. 5 pi over 4. 6/4, which is reduces to 3 over 2, right? And then 7/4. 7 pi over 4. And then we end up at 8/4, which is 2. Okay. Next, we need to get whatever's here, whatever's equivalent to 30 degrees. So we don't know that. Multiply by pi over 180. What does 30 over 180 reduce to? 1/6, yeah. So it's pi over 6. So that's going to be our first one here, pi over 6. And now we've got a new pattern. We're adding a 1/6 of a pi as we go around. We're always going to skip the middle ones now. So this is 1 pi over 6. Next one is 2 pi over 6. But we're not going to write 2 pi over 6 because it's not reduced form. It's pi over 3. If you write 2 pi over 6, it's wrong. That would be pi over 3. But you want to keep in mind what it is, how many 6 it is. So this is 2 pi over 6. 3 pi over 6, which is a half. 4 pi over 6, what does that reduce to? 4 over 6. Yep, 2 pi over 3. And it's 5 pi over 6. That doesn't reduce, so it's like this. 5 pi over 6. 6 pi over 6, which is 1. 7 pi over 6, that can't be reduced. 8 pi over 6 would be the next one, but 8 over 6 can reduce to 4 over 3. So 4 pi over 3. That was 8 over 6. Now it's 9 over 6, because that's 3 halves. 9 over 6. 10 pi over 6, which reduces to 5 pi over 3. And then 11 pi over 6, which can't be reduced. Okay, so that is the radians. So again, the pattern with the radians. For the quarters, it's 1/4, 2/4, 3, 4, 5, 6, 7, 8/4. With the other ones, it's 1/6, 2/6, which is a third, 3/6 and a half, 4/6, 2/3, 5/6, 6/6, 7/6, 8/6, all the way around. So you don't actually memorize the whole circle, you memorize the pattern of how you do this. All right, now the last thing is we've got some coordinate pairs we got to fill in out here. So let's start with the easy ones. Always just start with the corners. So I always recommend just starting with like your 4 corners. Keep in mind that I said this was 0, 0. It's the origin, right? And I said also that this unit circle has a radius of 1. So that means the distance from here to the edge is 1. And I also said think of this as sort of as your x-axis, right? And then the horizontal or the vertical one is your y-axis. So what would the coordinate pair be out here? Yeah, 1, 0. 1 in the x, and then you would 0 in the y direction. Okay, at the top, we're moving 0 in the x, and then up 1 in the y. So 0, 1. Over here, it's -1 in the x, 0 in the y. And then at the bottom, we got 0 in the x and -1 in the y. Those are the easy ones. Here's where it gets a little crazy. Anybody remember what these other coordinate pairs are? All right, I'm going to show you how they come up with these. You don't need to be able to replicate what I'm going to do, but I'm just going to show you where they came from. Right. So just kind of hang with me. You don't need to write this down for a few minutes, but I'm going to look at this in terms of a triangle. Okay. So if I were to draw a triangle like this, okay. So here's my triangle. I'm going to pull it out. This angle here is 30 degrees. Right? What would this angle up here have to be? Right, 60 degrees. If you think back to geometry, I'm sure you remember everything from then. This is a special right triangle. It's called a 30, 60, 90 triangle. The reason it's special is because there's an easy relationship between the three sides of this triangle. The relationship is that, let's say for instance, this is 1. Okay? That side is 1. Just making this up right now. The relationship is that the hypotenuse then is 2 times that small side. So this would be 2 times 1, which would be 2. And then this side is whatever the small side is times radical 3. So 1 times radical 3 over radical 3. That was the relationship. We would say that like this is n radical 3, and that's 2n. That sparked a little bit of a memory maybe. Okay. So I'm going to take this fact, and I'm going to change the numbers a little bit though, because I know what is the hypotenuse of this triangle. Huh? It's 1, yeah, because the radius is 1. So I'm going to just change this a little bit. Well, the only thing I actually know is that the hypotenuse is 1. But I do know that this is 30 degrees and then this is 60. I don't know the other two sides. So if this is 1, what is this side? All over. Huh? Yeah, it's a half. Yeah. Because this is always twice the other one. Okay? So this is a half. You multiply by 2 to get that one. Okay? Right? Twice the mistake. So then this side is whatever this short side is times radical 3. So it's 1/2 times radical 3. In other words, radical 3 over 2. Now what we've actually done is we came up with a coordinate pair of this spot on the triangle. Because this right here represents this distance here, right? That's the x-coordinate. Okay? See how this is the x-coordinate, right? Radical 3 over 2. And then the y-coordinate would be this part right here, which is a half. You can also prove this another way. Since these are right triangles, you could use the Pythagorean theorem to prove this. That would say that a squared plus b squared equals c squared. If I did radical 3 over 2 squared plus 1/2 squared, and that's equal to 1 squared, right? A squared plus b squared is c squared. So I square this. The square root of 3 squared is just 3. 2 squared is 4. 1/2 squared is 1/4. 1 squared is 1. So then we add the numerators, we get 4 over 4. So 1 equals 1. Another way to prove it. Similarly, this triangle here is the same, except it's just sort of rotated a little bit. This is a 60-degree angle here, and this is the 30-degree angle. So it's just rotated. It's the same triangle, same relationships. It's just flipped. It's just kind of, this is like, I don't know, landscape, and this is portrait or whatever. So what happens is these two just flip. So this is a half, and this is radical 3 over 2. Just flip flop. Oh yeah, you can have that. Yeah. See you on Monday. And then now to find the other missing coordinate pair. It's going to be this one here. Colors. Alright. So with this triangle, here, in this set of forms, right? And this is another special triangle. This is a 45-degree angle. So that's called a 45, 45, 90 triangle. What was the other special right triangle, if you guys remember? This had a special relationship as well. And this one, if I said this side was 1, what would this side be? Same, it would be 1 as well, right? We know that because they both are opposite of a 45-degree angle, so if they're opposite the same angle, the side have to be the same. And then do you guys know what the hypotenuse would be? Do you remember? So it'd be radical 2. So it's like whatever this is times radical 2, so like 1 radical 2. So you would say like this is n, this is n, this is n radical 2. I don't know if you ever had to memorize that in geometry. If you didn't, you should have. But everybody. All right, so let's use this fact to then find the coordinate pairs for that. All right, so in this one though, we know that the hypotenuse is 1 again, right? Because that's a radius. Does anybody know how I would get to these sides? So if we go from here to here, I multiply by radical 2, right? How would I go the opposite? By radical 2, yeah. So it would be 1 over radical 2. But we don't leave fractions like that. We don't leave radicals on the bottom. So you would then multiply this by radical 2 over radical 2, which leaves you with radical 2 on top and 2 on the bottom. Radical 2 over 2. And these sides we know are the same. So it turns out they're both radical 2 over 2. That would be the two sides. So what we found is the x direction here. This is the x, and this is the y. So this coordinate pair is radical 2 over 2, comma radical 2 over 2. So it's the same in the x and the y. Now the good thing is, there isn't like a separate set of directions for the rest of these. They're actually the same as this. It's kind of a mirror image. So all you actually have to do is memorize one quadrant. This first quadrant, this is quadrant 1. All you have to do is memorize that first quadrant because then the coordinates are going to be repeated in all the other quadrants. The only difference is going to be the signs. So if I were to look at, take for instance this coordinate, it's going to match up with this one. You can see how they're like mirror images of each other, right? So they're going to have the same coordinate pairs, except what's the only difference over here? Yeah. Right, yeah. X is always negative because we're moving in the negative x direction. Again, think of this as 0, 0. This is the negative x direction, positive y. So it's going to be negative a half, and then positive radical 3 over 2. So it's exactly the same as the mirror image on the other side, except we're going to make the x negative. So then this one matches with this one. Again, we just make the x negative. So negative radical 2 over 2, comma positive radical 2 over 2. And same with this one. Mirror images, negative radical 3 over 2, positive a half. And then we just repeat it again. So now we reflect it down. This one matches with this one. Right? See how they reflect, match up. And this quadrant, actually, so this is quadrant 2 if you've got quadrants. This one is quadrant 3. In quadrant 3, the x is negative and the y is negative. So we're going to keep the same coordinate pairs except they both are negative now. So this will be negative radical 3 over 2, negative a half. And this one is negative radical 2 over 2, negative radical 2 over 2. And then the last one is negative a half, negative radical 3 over 2. And then lastly, these reflect over to this side. So this one matches here. And in this one, the x is positive and the y is negative. So the x is positive, positive a half, negative radical 3 over 2, positive radical 2 over 2, negative radical 3 over 2, and positive radical 3 over 2. So that is the complete unit circle. And you don't have to be able to prove this, just showing you how it is proved. One thing to note, like, it is kind of hard sometimes to remember which one goes first, whether the radical 3 over 1/2 goes first. How I normally remember it is if I think of, let's just say this coordinate pair. Would you say this is longer in the x or the y direction? Get to this one. This one looks longer in the x direction, right? One further in the x and then shorter in the y. Yeah. This number, radical 3 over 2, is bigger than 1/2. It's a bigger number. Because the square root of 3 is 1 point something. It's a bigger number. So since I know I'm bigger in the x direction here, I want my bigger number as the x. And then also, if you just kind of look, if you were to just look over that in the y direction, that does look like a half, right? This does not look like a half. It looks like something bigger than a half. Same with this one. My x looks like it's a half. The y would be right here. That definitely doesn't look like it's halfway up. So I know my y is the right. If you have trouble getting this mixed up. All right, and then once you know those, you just replicate it all around. So while it might seem like a lot to memorize, there isn't really that much. You just really got to memorize the first quadrant, memorize the pattern around it. Seems doable now, right? You can do it. It's too late for that. All right, the last 14 or so minutes here, we're